All right, so this lesson is going to be on chapter 3, section 4. We're going to find the zeros of a polynomial function. Part of it we've done before, and then part of it's going to be completely new. But it all ties into what you guys were just tested on. All right, so this is what was on your last test. Now, this showed up in section 3.3. We know that the factor theorem is if we have our function equal to 0, meaning if our remainder, right, so I'm going to say if we use synthetic division and then we get our remainder equals 0, right, that number, right, is a 0. Right, this is what we said, what we meant, or what we did when we used a factor theorem in the previous section. All right, so if we get our remainder of 0, then we get that number is a 0, right? In other words, the divisor is a factor, right? So like I said, they mean the exact same thing. All right, so this is not new stuff, right? So this is stuff that you guys have seen before in the previous section. We're going to try to factor this function if x equals -3 is this should say 0. Right, this isn't a factor, this is a 0. And what we would do in the previous section is we would do synthetic division. So we would have a -3 in the corner, and then beside it would go our coefficients. And essentially, if you're given that x equals -3 is a 0, then you should expect a remainder of 0 at the end of your synthetic division. Right, so I'm going to bring down the 6. 6 times -3 is -18. 19 minus 18 is 1. 1 times -3 is -3. 2 minus 3 is -1. And -1 times -3 is 3. And we do, in fact, get a remainder of 0. Right, so that's what we expected. We knew that that was going to happen. All right. Now, with these numbers, right, these make up the coefficients of your quotient. Now, if you have an x to the third, you should expect your quotient to start with an x squared. So I'm going to have a 6x squared plus x minus 1 equals 0. And we can go ahead and factor this, right? So there's something in front of our x squared, so we're going to try to factor it by grouping, right? So 6 times -1 is going to get us a -6. And we want factors of -6 that add to 1. And that's going to be +3 and -2. So I can go ahead and split up that middle term, and it's going to be a plus 3x minus 2x. Bring down the -1, bring down the 6x squared equals 0. And then group. All right, so we get, over here we can take out a 3x, and then you're left with a 2x plus 1. Take out a -1, and you're left with a 2x plus 1. All right, so we get 3x minus 1 and 2x plus 1. All right. And now we set each of these equal to 0, right? So I'm going to bring this up here. 3x minus 1 equals 0, and we have 2x plus 1 equals 0. And so here we get x equals a third, and x equals -1/2. All right, so those are our two other zeros, right? So we were given one of them, and we found two more, right? And we expected 3 answers, right? So like I had mentioned way back when, if you see the highest exponent is 3, you should expect 3 answers. All right, let's try the same thing with the next one. Right, it gives us now that x minus 1 is a factor. Right, so if x minus 1 is a factor, that just means x equals 1 is a 0. And this is the number that we're going to use in our synthetic division. If they give us a factor, use the opposite of the number that you see. All right, so I'm going to put a 1 in the corner, and then you get a 2, -3, -5, and 6. Right, so it is a 0, meaning when you do our synthetic division, you should expect a 0 here. And let's just verify that that's true. Bring down the 2. Up here goes 2 times 1. -3 plus 2 is -1. Then you get a -1. And you do, in fact, get 0. Right, so that means this is now, or these are now the coefficients of your quotient. We have another cubic, right? So we should expect an x squared. So I have 2x squared minus x minus 6 equals 0. Let's see if we can factor this. Right, 2 times -6 is -12, so we want factors of -12 that add to -1. Is going to be a -4 and a +3. Right, so this one does factor. All right, so I'm going to have a -4x plus 3x, right, bring down the 6, bring down the 2x squared, and then you can group. All right, so I'm going to bring it up here. And then the GCF of our first group is going to be a 2x. We're left with an x minus 2. From our second group, we can take out a 3, and you're left with an x minus 2 as well. So you get 2x plus 3 as one of our factors, and x minus 2 is our other factor. So we get 2x plus 3 equals 0, and x minus 2 equals 0. Right? So one of our zeros is 2. Our other one, if you subtract 3 and then divide by 2, you get x equals negative 3 over 2. Right? And then one of them we got from the very beginning, right, when they told us that x minus 1 is a factor. All right, so this isn't particularly new, right? A little bit longer examples than what I showed you in the previous section, right? But essentially nothing is completely new. All right, same thing here. They give us now x equals negative 5 is a 0, so I'm going to go ahead and plug that into our synthetic division. Right, we should expect a 0 as a remainder. So 6, 17, negative 63, and 10. Right, so whatever we get here, we should expect a 0. Right, so I'm going to bring down a 6. 6 times negative 5 is negative 30. You get negative 13, 65, a 2, and then a negative 10. Right, so you do in fact get 0. And then your quotient is now going to be a 6x squared minus 13x plus 2 equals 0. All right, let's see if this factors. All right, 6 times 2 is 12. We want factors of 12 that add to negative 13. That's negative 12 and negative 1. All right, so I'm going to go ahead and split up this middle term. We get a negative 12x minus x. And then bring down the rest of it. Group the first two, group the second two. You can take out a 6x from the first group. You're left with an x minus 2, and you can take out a negative 1 from the next group, and you're left with an x minus 2. So you get 6x minus 1 as a factor. X minus 2 is another. And then you get x equals 1/6 and x equals 2, right? Set each of these equal to 0, and you get your other two zeros. All right, so those are two of them, and then we were given another one, right? So we have 3 zeros. All right, so the examples that we've done so far aren't super difficult. They're things that we've discussed in the previous section, right? So none of it was new. We were always given a 0. We were always given a factor that we know for sure is going to work, and then we just need to work with whatever we get left over, right, from our quotient after doing our synthetic division. All right, but sometimes you're not going to be given any information. Sometimes you're just going to be asked, find all of your zeros. Right, and in which case you're not going to be able to factor, you're not going to be able to use a given 0 because you're not going to have a given 0, right? So in this case, you're going to have to find all of your possible rational roots, right? And this is called the rational root theorem. Rational root theorem, right? And what we're saying here in this page is that if you don't know anything about the zeros of your polynomial, then you have a pool of options to choose from that for sure maybe some of them are going to work, right? Not all of them are going to be, not all of your zeros are going to be rational, right? Meaning you might get a radical number as an answer. You might get you might get some imaginary solutions. Right, and that's not accounted for in this. Here, we're just looking for any possible rational roots, right? So anything that can be written as a fraction, right? To do so, we're going to put the polynomial in a descending order, right? So this is in standard form, right? So decreasing degree, start from the highest, end in the lowest, right? Possible roots, any of your possible roots are going to be plus or minus the factors of the last. So the last factors over the first factors, right? Meaning the last term over the first term. And then to find all of your roots, you're going to test all of your possibilities until you get a remainder of 0. And then you keep going until you can factor it by hand, or you can use the quadratic formula, right? And I'll show you what this means later on. So these two examples are pretty difficult if you're just looking at it for the first time. But I'll show you what we mean when we want to find possible zeros, right? So in this page, I'm not going to work these out. I think I worked out number 5 in class. Number 4, I just listed out all the possible zeros. That's what I'm going to do here as well. As a matter of fact, I'm just going to, right, I'm not going to find all the zeros. I'm just going to list all the possible rational zeros. All right, and that was plus or minus, right, factors of the first, factors of the last over the factors of the first. All right, and factors of your last term you see is a negative 15. We can just use factors of 15 because we have a plus or minus out front. We're going to have positive and negative. So it doesn't really matter, right? So our possible zeros are going to be plus or minus factors of 15, which are going to be 1, 3, 5, and 15, right? All of these are factors of 15. Over factors of our first term, right? Our first term we see is this 8 right here. So factors of 8 are going to be 1, 2, 4, and 8. Right, and this isn't going to be your final answer. You're going to want to actually list them all out. It's going to be plus or minus. You have to go one by one, right? So everything on the top has to go over everything on the bottom. So I'm going to start with 1, 3, 5, and 15 over 1, right? I'm just going to put those all over 1, right? We have 1 over 1, plus or minus 3 over 1, plus or minus 5 over 1, plus or minus 15 over 1, right? So those are some possible zeros, right? Meaning any of these numbers, if we plug it into our function in our synthetic division, we should expect, hopefully, a remainder of 0, right? But these aren't all of our options. We have to keep going, right? Because we still have more factors of 8 on the bottom. So I'm going to put 1 over 2, 3 over 2, 5 over 2, and 15 over 2 as more possibilities, right? So plus or minus 1 over 2, 3 over 2, 5 over 2, and 15 over 2. Plus or minus, right? So I'll write plus or minus. All right, and then keep going, right? We have more factors on the bottom. We have a 4. So I'm going to put everything over 4. Plus or minus 1 over 4, everything on the top over everything on the bottom, right? So 1 over 4, 3 over 4, plus or minus, right? Plus or minus 5 over 4, and plus or minus 15 over 4. All right. Lastly, I want to put everything over that 8. The 1, 3, 5, and 15, put all of those over 8. So I'm going to get 1 over 8, 3 over 8, right, plus or minus, plus or minus 5 over 8, and plus or minus 15 over 8. All right, so all of these are possible rational zeros, right? So if you were present in class, you hopefully know that from this point, if you want to find all of your zeros, you would have to test some numbers, right? Plug it in, do synthetic division, and see which one gets you a remainder of 0. Like I said before, I'm just going to list them for this example. If this is confusing so far, the next slide we actually find all the zeros given a function, right? So hopefully that'll clear this up. But for now, this is just what it would look like if we were to list out all of the zeros, right? And anything over 1 we can simplify, right? So we can get 1 over 1, 3 over 1, 5 over 1, and 15 over 1. Those are just going to become 1, 3, 5, and 15, right? So simplify anything that you can simplify. All right, so let's do the same thing with the next one. Right. Again, I'm just listing the possible rational zeros. I'm not actually going to solve this one. In class, I solved it because you guys saw the next slides first. All right, but this time I'm just gonna again list out the possible zeros. So it's going to be plus or minus factors of the first. Factors of the last, and our last is going to be 2. So factors of 2 over factors of our first, which is 6, right? So it's going to be plus or minus factors of 2 is 1 and 2. Factors of 6 are 1, 2, 3, and 6, right? So again, just like the last one, I'm going to have everything on the top over everything on the bottom. So our possible roots, our possible rational roots are going to be plus or minus 1 over 1, plus or minus 2 over 1. All right, now let's put everything over 2. 1 over 2, plus or minus 2 over 2. All right, everything over the 3, plus or minus 1 over 3, plus or minus 2 over 3. All right, now put everything over 6, plus or minus 1 over 6, plus or minus 2 over 6, right? And these fractions you can simplify, right? So 1 over 1, for instance, that's going to just become 1, right? 2 over 1, that's going to become 2. 2 over 2, that becomes 1. All right, and then 2 over 6 is another one that simplifies. That becomes 1/3. Right, so notice that, whoa, what did I do? All right, notice that 1 repeats. We have a 1 here and another 1 here, so you can scribble one of them out. We have a 1/3 here and another 1/3 here, right? So again, you can scribble one of them out. Right, if it repeats as a possibility, I mean, it's possible for an answer to show up twice, but that's true regardless of if it shows up twice in your list. Right, so this is your pool of possibilities. So again, if you were present in class, hopefully you know that from here to find the rest of our zeros, we would choose a couple numbers until you get one that gives you a remainder of 0. Again, we're not going to do that for this example. I'll do that for the rest of the ones on this in this lesson. All right, so for these, I want you to find all the zeros, right? And let's do that together. Now, just like before, we're not given any zeros here, right? So something like this, x cubed plus 4x squared minus 5, we can't factor that, right? We can't take out a GCF. There's no 4 terms for us to group. And we can't do what multiplies to -5, what adds to 4, because this is not a quadratic, right? So we need to have a couple options to choose from, right? So here we're just guessing, right? But we're not guessing arbitrarily. We're guessing based on factors of the last over factors of the first. So it's going to be plus or minus factors of 5 is going to be 1 and 5. Over factors of the first is just 1, right? So there's a 1 in front of our x cubed, right? So these are a lot simpler options to choose from, right? Because anything over 1 is itself, right? So we get plus or minus 1, and plus or minus 5 over 1 is 5, right? So these are our only 4 options. We get 4 options to choose from, right? So let's pick one of them. I always pick 1 to start with. If 1 doesn't work, I go -1. If -1 doesn't work, I go the next highest number, and then the negative of that next highest number, and so on until you get one that works, right? So some of these are a little bit tedious because sometimes you have to do it a couple times before you get a solution that works, right? And that's what makes these problems a little bit more difficult than some other ones that we've done before, because you're not sure which one works until you try it. So I'm going to try 1, and the objective here is we want to use synthetic division and see if we get a remainder of 0. So I'm going to have a 1 in the corner, a 1, a 4, a 0, and a -5. All right, so let's bring down the 1. 1 times 1 is 1. 4 plus 1 is 5. 5 times 1 is 5. 0 plus 5 is 5. 1 times 5 is 5. And -5 plus 5 is 0. So our first option worked. So we get x equals 1 is a solution, is a 0. Right? Because we used synthetic division with 1 and it worked. We got a remainder of 0. So now let's see. 1, 5, and 5 make the coefficients of a quadratic. Whether or not we can factor a quadratic, we can solve it. We can get our zeros. Right? So this one's not factorable. Right? There are no factors of 5 that add to 5. So unfortunately, we have to do quadratic formula. But that's fine, right? We know how to do that. Right? Even though it's a little tedious, we should know how to do it. And now we turned this problem into something that we're able to do. Right? So let's plug this into our quadratic formula. We get x equals -5 plus or minus the square root of 5 squared minus 4 times 1 times 5 over 2 times 1. All right, and then so we get -5 plus or minus the square root of 25 minus 20 over 2. And then that's going to get us negative 5 plus or minus the square root of 5 over 2. All right, so these are our other two solutions. Notice that 1 is the only rational solution that worked. Meaning if you picked 5, negative 5, or negative 1, you would get that they didn't work because these, as you can see, the ones with the radical, are not going to show up in your possibilities, right? You only get rational possibilities, right? So anything else, any other real numbers, you're going to have to figure out just based on whatever you get left over. In this case, we use the quadratic formula. All right, so those are our 3 zeros, right? We get 1 that we found, and then we get 2 here. All right, and we were expecting 3 solutions because we have a cubic polynomial. All right, so let's do the same thing with the next one. All right, so for this next one, we're not given any zeros, and this isn't something that we can factor. Right, so we want to find possible zeros, right? So I'm going to write possible rational zeros, right? And that's going to be plus or minus factors of the last. So 3, factors of 3 is 1 and 3, over factors of the first. Our first term is a 1, right? So our possible rational zeros are going to be positive or negative 1, positive or negative 3, all right? So again, very small pool of numbers to choose from, right? So I'm going to pick 1, right? I always like to pick 1 to start and see if that works. So we have a 1, 0, 2, and negative 3. All right, so let me go ahead and do the synthetic division, bring down the 1. 1 times 1 is 1, 0 plus 1 is 1, 1 times 1 is 1, 2 plus 1 is 3, and 3 times 1 is 3, and then we do in fact get a remainder of 0. So because 1 works, we have x equals 1 is a solution. So then we get x squared plus x plus 3 equals 0 is our leftover quadratic, it's our quotient. And then we check, can we factor this? Right, so this one cannot factor. But that's fine because we don't have to keep doing our rational root test. We would just use the quadratic formula. We know how to use the quadratic formula, right? So I'm going to plug it in. Negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 3 over 2 times 1. And then let's see what we get from this. We get negative 1 plus or minus the square root of 1 minus 12 over 2. And this gets us negative 1 plus or minus the square root of negative 11 over 2. And then if there's a negative under the radical, take out an I. We get negative 1 plus or minus I root 11 over 2. All right, and those are your 2 other solutions. So we get 2 solutions there, and we had 1 real solution that we found at the beginning. All right, so that's your strategy here. You're just picking rational zeros from your list of options and just seeing which one works. Right, so that's how you're going to tackle these problems if they don't already give you a factor or a 0. All right, let's try the same thing with this one. Right, so I'm going to have my possible zeros, or my possible rational zeros, right, and I'm going to list them out because we're not given any information, right? We're not already given a rational zero, so we need to pick one, figure it out. Right, so it's going to be plus or minus factors of the last over factors of the first. Our last term is 8, so it's going to be 1, 2, 4, and 8, right? Those are all your factors of 8. And your first term is 1, right? There's a 1 in front of your 5, so it's 1x to the 5th. And so that just leaves us with the 1 on the bottom. That means all of your rational zeros are going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Right, so pick any of these to start with. Again, I always pick 1. So I'm going to put a 1 in the box. Right beside it are going to go the coefficients of your function. And it's going to be a 1, 0, 1, 2, negative 12, and 8. All right, so I'm going to bring down the 1. 1 times 1 is 1. All right, so I'm just going to go through this. All right. And it looks like 1 does work, right? We get a remainder of 0. That means x equals 1 is a solution. Okay, so that's one of them. And then let's see what we have left over. We have an x to the 4th plus x to the 3rd, right? So these numbers are going to become the coefficients of your quotient. since we started with an x to the fifth, our quotient should have an x to the fourth. So x squared plus x to the third plus 2x squared plus 4x minus 8 equals 0. And let's see, can we do anything with this? Can we factor it? Can we take out a GCF? We can't group it, right? There's 5 terms, right? It doesn't look like we can do anything with it. So what do? We repeat the whole process, right? Only this time using these as your coefficients and not the ones from your original problem, right? So I'm going to use 1, 1, 2, 4, and -8 as the coefficients of your synthetic division, and you have to repeat this process again until you get something that you can factor or use quadratic formula, right? And again, we have a 1 as your first term and a -8 as your last term. So we're going to have the exact same possibilities. I'm going to pick 1 again because it could work twice, right? It could have a multiplicity of 2. So I'm going to try it again, and I'm going to see if it works. Bring down the 1. We get a 2, bring up the 2. We get a 4, bring up the 4. We get an 8. And we get x equals 1 again, right? So what does that mean? If you have a number show up twice as an answer, remember that just means it has a multiplicity of that number, right? So multiplicity of 2, right? So x equals 1 showed up again. So we have an x squared plus 2x, I'm sorry, not an x squared, x cubed. X cubed plus 2x squared plus 4x plus 8 equals 0. All right, and I'm gonna group, right? This one can factor, right? We factor it by grouping. So that's what I mean. You keep going until you get something that you know what to do with it, right? Before, we can't do anything with this. All right, nothing with that. But this quotient, we're able to group and factor, right? We can take out an x squared from the first group, and you're left with an x plus 2. From the next group, you can take out a 4, and you're left with an x plus 2. All right, and so we get x squared plus 4, and x plus 2 equals 0. All right, so one of our zeros is going to be -2. The other one, we get x squared equals -4. When we square root both sides, we get x equals plus or minus 2i, right? So we get 2 imaginary solutions, another real solution, and then we have our one solution up here that we found that had a multiplicity of 2. So that does account for our 5 solutions, right? We had one show up twice, we had 2 imaginary, and then another one. All right, and that's what we were expecting with this degree, right? If we have a degree of 5, we should expect 5 zeros. All right. So that's all for this lesson. We're going to do some more practice with graphing, right? So you might have some graphing problems on your quiz, but you're going to have some similar to this one where you have to find or list the possible rational zeros and then use that to find all of the zeros of your function, right? So I know it's a little tedious, but hopefully not super difficult, right? If you understood the previous lesson, then this shouldn't be any more difficult, right? Maybe a little time consuming, but shouldn't be super bad.